Good morning, friends. Thank you for joining me in our first remote math lesson. What you are going to need with you today to participate, clearly you have your computer in front of you. You want to make sure that's charged every day for class. You're also going to need your Volume 2 Pearson workbook and a pencil. So as long as you have those materials with you, you're going to be all set to get going. So I'm going to try and keep the format of these remote lessons pretty similar to what we would do in class. So we're going to start with a warm-up problem. We're going to do that pretty much on our own and then go through corrections together. We're going to work through the 3 examples together for each lesson, and then you're going to do the classwork on your own. You'll pause the video. I will then provide corrections when you're ready to make them. The main thing that's going to be different, besides for us not being in our classroom together, is the format of the homework. So instead of having you do the page that we usually complete for homework at the end of the lesson with the assessment practice, I'm going to have you do the Math Excel learning that goes along with each lesson online. So I will assign that through Pearson. It will show up in your Google Classroom, and you'll be able to complete the work there. So the reason for that is that it'll be corrected instantly. There are tutorial videos that go along with each problem. It's the extra practice that we generally use before a test, so we'll be using it instead for homework. Just because of the reasons we talked about, it'll be a little bit easier to use. Okay, so we're going to start topic 6. So topic 6 begins on page 330. So if you want to flip to page 330, looks like this. I have actually a different page open on my screen, but we're going to start on page 330. Okay. So it says understand and use percent. So we're going to be talking about percent. It is a rate. So percent is a rate where the second term is always going to be 100. So you can think of percent as a fraction where the denominator is always going to be 100. We use percents in a lot of different ways in our everyday lives. We use percents to calculate discounts, to calculate tips. We talk about percents in a lot of sports statistics. We talk about free throw percent in basketball. We talk about percents all the time in a lot of different ways. I would say most of you complete your homework about 95% of the time on a good week. So we talk about percents in a lot of different ways. We're going to start with a problem, our warm-up problem on page 335. And it actually does not directly deal with percent, but it's going to show us how we can use fractions in our conversation about percents. Okay, so I'm going to read the problem to you, and I'm going to have you try it on your own. So it says Tom made a vegetable pizza and a pepperoni pizza. He cut the vegetable pizza into 5 equal slices and the pepperoni pizza into 10 equal slices. Tom's friends ate 2 slices of vegetable pizza and 4 slices of pepperoni pizza. So I want you guys to use the rectangles provided to try and make a visual to help you solve this problem. And I want you to go ahead and try it now. So you're going to press the pause button on the video, you're going to try the problem, and you're going to press play when you're ready to hear the solution. All right, so I hope you had a chance to try the problem. If we are looking at part A asks us to draw lines on each rectangle to represent the equal slices into which each pizza was cut. So we're going to start here with our vegetable pizza. I'm going to start with our vegetable pizza, and I'm going to try and make equal sections, although, as you guys know, my drawing skills are not wonderful. So we have 1, 2, 3, 4, 5 pieces of pizza in the first vegetable pizza. So our first pizza is a vegetable pizza and it's cut into 5 slices, 5 equal slices. And our second pizza is a pepperoni pizza and it's cut into 10 equal slices. So you may notice that our pepperoni pizza is going to have twice as many slices as our vegetable pizza. So I'm going to first cut the pepperoni pizza into fifths, and then of course to get to tenths, I'm going to need to cut each fifth in half, because a tenth is half the size of a fifth, as you guys well know from our work in fractions. So I'm cutting the pizza into tenths here. All right, these are not perfect, but they will work for us. All right, so our pepperoni pizza should have 10 slices. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slices of pepperoni and 1, 2, 3, 4, 5 slices of vegetable. Okay, so we have completed the first part of the problem where it asks us to divide the two rectangles into these amounts of slices. The second part asks us, Tom says his friends ate the same amount of vegetable pizza as pepperoni pizza. How could that be true? So if we're looking at the problem, we know that Tom's friends ate 2 slices of vegetable pizza and 4 slices of pepperoni pizza. So could they have eaten the same amount? What we should ask ourselves is, are the slices the same size? And the answer is no. The vegetable pizza, the slices are twice the size of the slices of the pepperoni pizza. So this is possible. What we're going to do is we're going to use the diagram we've created, and we are going to shade in. We're going to use red. Actually, let's use green for our vegetable pizza. Green, like, oh, it didn't work. It's in black. Let's try again. And try that. Green. There we go. That should work. So now we have green is going to be our vegetable slices. So we have 2 green vegetable slices. And I'm going to label my fraction of the pizza consumed over here on the left. So I'm going to have 2/5 of the pizza that was consumed for the vegetable pizza. And I'm going to go ahead and do the same thing for my pepperoni pizza. And it is indicated in the problem that 4 of the 10 slices were consumed. So 1, 2, 3, 4. Right, I'm going to shade in the pepperoni pizza a little over the line there. Okay, so we have 4/10, and I'm going to write that over here. We have 4/10 of the pepperoni pizza that was consumed. So now we're being asked, are these two amounts equal? Did his friends eat the same amount of vegetable as pepperoni pizza? Is 2/5 equivalent to 4/10? The answer would be yes, as we know from our work in equivalent fractions. So we can multiply both the numerator and the denominator in 2/5 by 2 to get 4/10, and we can tell that those are equivalent fractions. If we were to produce a fraction for each of these pizzas, the amount of pizza consumed that was equivalent to 100, that would give us a percent. So if we had in the denominator of each of these problems 100, that would give us a percent. So if we did 2/5, we said 2/5 is equivalent to, we're going to multiply, let me write this up here. So if we have 2/5, and I want to create a fraction that is equivalent with a denominator of 100. So how am I going to get from 5 to 100? Well, I know that 5 times 2 is 10, and I need to get 10 times larger than that. So 5 times 20 is going to get me to 100, right? We know, so we have 20, 40, 60, 80, 100. 20 goes into 105 times. We're going to do the same thing on the top. So we're going to do our numerator, 2 times 20 equals 40, okay? So what we just did is we created a percent from 2/5 by making it an equivalent fraction over 100. So if we have 2/5 equals 40 over 100, that means that 2/5 is equivalent to 40% of the pizza. So that means 40% of the vegetable pizza was consumed. Now let's take a look and see what percent of the pepperoni pizza was consumed. This is a little bit easier just because it's so simple to get from 10 to 100. We're adding 1 0, we're moving the decimal place over 1 to the right, which means we must be multiplying by 10 to the first. So if we're multiplying 10 by 10 to the first, also known as 10, right? So times 10 times 10. We're going to multiply 4 on the top, also times 10. 4 times 10 is 40. Okay, So 4 over 10 also equals 40 over 100, right? So these both represent 40%. So 40% of the vegetable pizza was eaten, 40% of the pepperoni pizza was eaten, the same amount was eaten of both pizzas. Now, what if we had a third pizza? What if we had a very controversial pineapple pizza, let's say, and we had, instead of 4/10 of pizza, imagine there were 20 slices of pizza. They were cut then again horizontally. Imagine we had 8/20 of the pizza. We would multiply the numerator and the denominator both by 5 to get an equivalent fraction with a denominator of 100, and we would still have 40% of the pizza, right? So it depends not only on the amount consumed, but also on the size of the slices. All right, so what we're going to do is we're going to turn to the next page. So you guys are going to turn to page 336, which I can do. What I have pulled up on the screen here is the Pearson Student Edition that's interactive. So you guys have access to this as like a PDF file on your computer. And I'm going to ask you to use this to follow along. So this is what will show up in your workbook. This is also what will be on your screen if you're using the Interactive Student Edition online. What I'm going to use is a teacher video that corresponds with what's in your book. Instead of playing this whole video for you, I'm going to use portions of it, and I'm going to explain as we go along like we usually do in class. All right, so the first thing that's here, and again, if you're following along in your workbook, which is what you should be doing, all right, we're at the top here of page 336. So if you're in your workbook, you should be on page 336 following along with me. All right, so a percent is a rate in which the first term is compared to 100. So it's a rate. You have your first term, and then your second term is always going to be 100. The denominator is always 100. We're always talking about out of 100 if we're talking about percent. I like to think about the word percent broken up. So we have per, which we know can be represented by the fraction bar, the division sign, miles per hour, right? Minutes per mile. And here we can think about percent. That word cent actually means 100 in French. So cent is 100. So we think per cent per 100, right? So a percent is going to be a fraction with a denominator of 100. Okay, just like a unit rate had a denominator of 1, a percent is always going to have a denominator of 100. Okay, so a percent is a rate in which the first term is compared to 100. The percent is the number of hundredths that represents the part of the whole. What percent of people prefer bright white toothpaste? So here we're being asked about a toothpaste brand, okay, and we're being given a visual here, and it shows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tubes of toothpaste, and 7 of them are shown, and 3 of them are kind of in silhouette there. So it's the idea is that those last 3 tubes of toothpaste on the right are not representative of the people who prefer bright white toothpaste. So what we can see here is that 7 out of these 10 people prefer bright white toothpaste. So what are different ways, and we're given 3 ways here, what are 3 different ways that we can represent percent visually? Okay, so the first way we're going to talk about, and this is going to be a really common way that you'll see percent represented, using a hundredths grid. So you guys have used hundredths grids before. It's called a hundredths grid because the dimensions are 10 by 10, and there are 100 little squares in this grid. So it's a 10 by 10 grid. Excuse me, it has an area of 100 small squares. So each square that's shaded in represents 1% because each square represents 1/100th. Okay, so here we can also see that each column going from top to bottom is going to represent 1/10 of the total grid. Okay, so we have 1, 2, 3, 4, 5, 6, 7. We have 7/10 shaded in, which is equivalent to 70 hundredths. All right, so this video is about to cut out. It's in 15-minute increments. So you're going to pause here and you're going to click on part 2 of the lesson 6-1.